This is Algebra 1, Semester 2. This is the unit on quadratics. This is lesson number 15. There's a lot of them in this one, in this unit. This is X and Y intercepts practice. It's on creatormath.com under the Algebra tab. You might have to type into Google creatormath.weebly.com to get to the site. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So to model where the notes are, right, that's an important part of this step. Let's see if I can get there. Sorry about that. So make sure you're on creatormath.weebly.com. Here's what the home page looks like. That's how you know you're on the right site. Go to Algebra. Pass the vocabulary stuff down to the table of contents. Here's Semester 2, table of contents. This goes on pages 2 through 6 of your composition book. You copy all this in, and by now you should have all this copied in. We're scrolling down to quadratics unit. We're scrolling down to number 15, right here. X and Y intercepts. It gives you a page to put the notes on and these problems we're doing right now. Follow the actual table of contents on the website, not this video, because by the time you see this video, it's probably different, right? So just follow the actual table of contents. Here's how you get to notes. Click on the tab that says notes, or I guess it's a link. Click on the link that says notes. Sometimes mine doesn't update. I'm watching it now. It did not update. You might have to reload it. There we go. So far, every time I've had to load it twice, it's loaded on the second run, but I imagine I'm going to hit a time where I have to load it more than once. So this talks about X and Y intercepts, talks about how to find them if you have a factored trinomial, talks about graphing on Desmos.com. Talks about things like use the zero property rule, the zero product property rule to find the x-intercepts and enter the zero for all x's and for all x's to find the y. Okay, so it's talking about you're entering the zeros, zero for x's to find the y-intercept. X-intercepts are called zeros, roots, the location where the graph crosses or intersects the x-axis. Y-intercept, the location where the graph crosses or intersects the y-axis. Definitions, zero product property rule, or rule, what the vertex is of the parabola, and some examples. Okay, so you're copying those notes into your comp book first, then you're trying to do these problems, and you're using this video to back you up if and when you get mixed up. We're also going to use Desmos right here in a second, and it says hint, graph the functions on Desmos.com, all right? It's telling you to do that. Given the following quadratic, find the x-intercepts and the y-intercepts. It's got s there, but there's going to be 1 if it's a parabola, right? There's not going to be more than 2 in a parabola. There's only going to be 1. So let's look at what they give us. They give us a trinomial, and they factor it for us. So if we did FOIL on this, x squared, right, outside would be 9x, inside would be minus 3x. 9x minus 3x is 6x, and the last term, negative 3 times 9, would be negative 27. So these are equivalent. We can plug those into Desmos to show that. We'll do that in a second. What we're trying to find are the x-intercepts. We're using the zero product property rule, which means that if you have something equal to 0, so we're going to put y here, y equals to 0. Why? Because when if this is our parabola, right? If this is a root or an intercept here and here, the value on the y-axis right here is 0. Y must be equal to 0 for us to find this point and this point. Once we make this equal to 0, we have 0 equal to x minus 3 times x plus 9. If we, anything that has to multiply to equal 0, this is either equal to 0, or this is, or both are. So we take x minus 3, put it equal to 0, and solve for x. Plus 3, x equals 3. So that's one of the roots. There's a root here at 3. We take this one, put it equal to 0, x plus 9 equals 0. We subtract 9, and x equals negative 9. So there's 1 over here at negative 9. Those are the two roots, so I'm circling this answer. Then when we go back and make all of the x values equal to 0, if this were 0 and this were 0, because the opposite's true, where this thing crosses the y-axis here, and again, this is the 15th lesson in this quadratics unit, so I'm going a little bit fast over this. This is not the first time you've seen this, right? This is back in the other lessons. If you've been going lesson by lesson, this should be very repetitive. I'm just reviewing it for review's sake. So where the x is equal to 0 here, that's where we're going to find where the y-intercept is. So if we make this term go to 0 and this term go to 0 right here, they disappear. We're left with the y-intercept of y equal to minus 27. So there it is right there. Check, check, check. Those are the three things we've got going right now. Let's go to the next, and I might go a little bit quicker. No, let's not go to the next. Before we do, let's go to the Desmos.com calculator here, right here, desmos.com, right? It'll say calculate, click that. Let's type in our quadratic. So we have f of x, f, parentheses, x, equals x squared plus 6x and minus 27. All right, notice that this draws the parabola for us. And if we click on these roots here, it'll tell us what they are. So here's one, minus 9, 0. Here's the other, plus 3, 0. Right? It'll tell us what the y value is here too, negative 27. So we can use Desmos to do all these problems. Just type them in. The other thing I'd like to show you is the factored form also the same? And let's type that in. I'm just going to say y equals, because it's too much to type f of x equals, which is equivalent in, this is a function form, this is just the graphing form of y equals. If we say y equals parentheses x minus 3, parentheses, x plus 9, parentheses. Notice both my purple parabola and my green parabola are on top of each other, right? They are the same equations. So if I take out this one, put this one back in, they're right on top of each other, right? So I've proved that with Desmos. You can type all these into Desmos. Now I'm going to run a little bit faster as I run through these. I'm going to go, I know exactly to put these equal to 0, and if I do, it flips the sign of, if it's x minus 6, it's going to be equal to x plus 6, equal to plus 6. This one's x minus 8, it's going to be x equals 8. So I know it's 6 and 8. I know that when I put everything to 0, it's this tail term here, 48. I can identify the two roots in the tail now extremely, very quickly now that I've done all that work. And I'm going to roll through these others very quickly now, given the base of the first problem that we did. So we took a little bit of time on the first one. Now I'm just going to go with all the things I know about this. And I'm going to literally go, this has to be x equal to 5. This has to be x equal to 9. And this has to be 45. 5, 9, 45. This has to be minus 63. I don't even see any with minus 63. I'm already done. But I know this is x equals 7. Check. And this is x equals minus 9. Remember, they switch signs because you put them equal to 0 and solve, just like we did in the first. If you don't know that, go back and just watch the first one again. And this becomes very repetitive. Do they give us any? Let's see. Anything interesting here? This is kind of interesting, right? It's x plus 11 squared, which we know is x plus 11 times x plus 11. Well, If I solve any one of these, put it equal to 0, and solve, I get x equals minus 11. But if I did it for this one too, I'd also get x equals minus 11. So they both solve for the same thing. There's only one. What's happening is the parabola at minus 11 is touching, the vertex is right on the x-axis. Therefore, you only have one root. And so I don't know if you're kind of seeing this option here, but this is for later. If a parabola is like this, there's two roots. If a parabola is right on the x-axis, there's one root. And there's another case, if the parabola is above the x-axis, there are 0 roots. And what happens there is, we start to get in the world of imaginary roots, right? So we'll talk about that later, probably not until Algebra 2. All right, let's go to the next one. This one's got the same situation but reversed. I know it's x equals 11. There's one of them. I know that this is 121 because that's where it crosses. By the way, that was 121 there. So I can find, if you give me a quadratic and I can factor it, I know that the roots, x are 11 and positive 11, negative 11, and negative 21. I know it the second I see it. And I guess that's why they just keep giving it to us. It's got to be x equal to minus 6. So I know there's a minus 6, and I know there's a 36 for the y-intercept. Math is a strange thing. If you don't know it, it's impossible. But once you know it, I would argue it becomes so simple that you're like, okay, what do I do now? I just get bored with this, right? This is x equals minus 5. This is x equals minus 3. So it's two worlds. You either know it or you don't. It's either impossible or it's easy. And there's kind of no in-between ground, you know? So x minus 5, x minus 3, and this is the tail term there. That's got to be where the y-intercept is. X equals 8, x equals 5, and 40. Two more. Finally, they give us something interesting. What do I do here? Go back, just put it equal to 0 like we know it is according to the zero product property or rule. Subtract 2 from both sides. 3x equals minus 2. Divide both sides by 3. X equals minus 2/3. There, finally something exciting. So here, x equals minus 2/3. Check. I can see my tail is negative 36. Check. This one's easier to do. X equals minus 6. Check. A two-step equation I use to solve it. Can I do this in my mind? Yes. Should you be able to? Yes. But at first, do it the long route. Prove it to yourself first, and then go back and just sort of imagine doing this and do it in your mind. At some point, we don't want to write out all the math. I know you're going to have math teachers that say write everything out. And you see me write a lot out. But at some point, I know this is x is minus 7. I know this is x equals plus 9. So minus 7 plus 9, and I know this has got to be y equals negative 63. Go back and make sure you're matching up the correct unit and lesson on this video with the one on creatormath.com under the Algebra tab. This is Algebra 1, Semester 2. It's the unit on quadratics, number 3, and it is the 15th lesson, x and y-intercepts practice, and I hope this helps.